Hello everyone, welcome to our channel 2 Bits. We have already discussed about some basic terminologies related to trees and how to implement a binary tree. Make sure to watch that before moving on forward. Now in this video, we will discuss about some binary tree traversal techniques. There are three traversal techniques mainly: pre-order, in-order and post-order. These techniques follow a rule which is basically how the function calls are made in them. So pre-order follows node, left and right, and in order follows left, node, right, and post order follows left, right and node. Now let's see how this works in some more detail. So we know that pre-order follows NLR. What does that mean? It means that the current node will be processed first, then the left, and when the left is complete, then the right will be processed. Now let's see how it is done. So we go to the first node, we see that the node needs to be processed, so we print the data of this node. Then when the node is done, we see that we need to go to the left. So we go to the left, we see that the node needs to be processed, so we print the data of the node. Then again we go to the left, we process this node and print the data. Then the node is done, we see that there is no left, so the left is done, and we see that there is no right, so the right is done. Then we go back, the left is done, then we see that the right needs to be done. So we go to the right, we see that the node needs to be processed, so we print the data. Node is done, there is no left, there is no right, we go back, right here is done. Then we go back here, we see that the left is complete. Then we go to the right. Again we see here node needs to be done, so we print 3, go to its left, here we do this node, print 6, there is no left, there is no right, we go back, left is done, we need to go to the right part, then here we will print 7, this node is done, there is no left, there is no right, we go back, right is done, we go back, right is done. So this was the pre-order traversal for this particular binary tree. Now let's see how we are going to make the function calls. So what we were doing was, we were printing the data of the root. Then we needed to call the left. So suppose there is a function named pre-order, and we will send the root dot left part. Then we needed to make a call in the right. So again we called that function pre-order and make a call to the right part. So these are the three important calls that we need to make. Now let's see another example in case of in order. So in order follows L and R. After we traverse the tree in order, we will get this as our answer. So the calls for in order will be, first we need to go to the left, so root dot left. Then we need to print the value, so we will print the root dot val. Then we need to make a call to the right part. So this will be the calls for the in order. And similarly, we know that the post order follows LRN, so we will make the calls in the similar manner. Now let's see how this works through the code. So this is the code for the pre-order traversal. In this we are given a root of the binary tree, and we need to return the array which consists of the pre-order traversal. So what we need to do is, we need to store all the values in the array, and then we need to return that array. So what we did here was, we took an array named answer and we made it global so that we can return it later and put in all the values. You can also pass answer as a parameter in the function. So let's say we have our answer here, currently it is empty, and we made a call with the root. So we made a call to the pre-order function, let's suppose this, and we pass the root. So currently root here is 3, so we pass 3. So the first statement says that if root is null or not. So we pass 3 as the root, so it is not null, so we will skip this. Then we append the value of the root to our answer. So the value is 3, so we append 3 in the answer. Then we made a call to the root dot left. So this will make a call to root dot left, that is 4. So when this call is made, again we go to the function, we check if it is null or not. It is not null, then we move to the second statement, answer.append root.value. So we will append 4. Then again we go to the left and make a call. So left of 4 is 6, we make a call for 6. Again we check if it is null or not. We go to the beginning of the function, we check it is not null, so we append the value of the root, that is 6. Then we go to this statement, see that we need to make a call to root.left. So we make a call to root.left. So left here is currently null, so we will pass null. So we see that when this statement comes, we see that root is null, so we will simply return. So this statement returns back. Then as this call was made, it is processed, we return from that because it was null. Then we make a call to root.right. Again we will make a call to root.right, and again we will pass null. So as the root is null again, so we will simply return. This call will also return. So we have processed till this node and we made all the 3 calls for it. Now this will return and we will go back to 4. Now for 4 we made a call to the left. Now the left part is complete, so we will make a call to the right of the 4. So it will call root.right, so it will make a call to 7 as 7 is in the right of the root. So we go to 7, we see that it is not null, so we will append the root value in our answer. Then we will make a call from left of 7, we see that it is null, so it will return null. And then again we will make a call to the right of the 7, again it is null, so we will simply return. So 7 is also processed. So after that it will return to 4. Now the left and right of 4 is processed, so it will return back to 3. Now the left side of 3 is processed and we get this in our answer array. Now we will go to the right, as the left call was done. Now this statement is left, so we'll make it call to the right of 3. So we see that we have 5 in the right of 3, so we will make a call for 5. Now in the call for 5, we will check if root is null. No, 5 is not null, so we will append the root value in our answer. So 5 will be added. Then we will make a call to the left of 5. So we see that we have 8 on the left, so we'll make a call for 8. Again we will check if root is null. No, it is not. We will append the value in our answer. Then we will make a call to left of 8. We see that it is null, so it will simply return. Then we will make a call to left of right. We see that it is also null, so it will return. So both left and right of 8 are processed, so it will return back to 5. Then we will make a call to the right of 5. So we will call for 9. We will check if root is null. No, it is not null, so we will add 9 in our answer. Then we check left and right of 9, both are null, so we will simply return. And after processing 9, it will return back to 5. So left and right of 5 are complete, so it will return back to 3. Now for 3, left was already completed, now right is also completed. So this function call is completed, and this will be the answer array at the end, which we will return here. So this was the code for pre-order traversal. Now for in-order and post-order traversal, the code is exactly same, just we need to change the order of these statements here, which we have already discussed. So do that and let me know in the comment section if it was correct or not. Thank you for watching. The link for the Python and C++ code are in the description, and the link for our Telegram channel is also in the description. Please join that and like the video and subscribe to our channel.